Jai Hind everyone, I am from Indian Space Team Rocket Science Division. Have you ever wondered what propels rockets into space? Have you heard about hybrid rocket engines, and do you know why they are significant? When we talk about rockets, we often think of massive structures being launched into space, but the real magic happens within those structures. One of the most fascinating and important parts of a rocket is its engine, and today we're going to talk about a particularly intriguing type, the hybrid rocket engine. In the simplest terms, hybrid rocket engines are a kind of rocket engine that combines aspects of both liquid and solid rocket engines. They use a solid fuel and a liquid or gaseous oxidizer. Imagine a birthday candle. The wax is the fuel, the flame is the oxidizer, and the combination of the two creates the thrust needed to propel a rocket. But why are hybrid engines significant? Well, they offer a unique balance of safety, efficiency, and control. They're safer than traditional engines because the fuel and oxidizer are stored separately, reducing the risk of accidental explosions. They're also more efficient, as they can be throttled and shut down mid-flight, unlike solid rocket motors. This ability to control the engine's power output gives a high degree of flexibility during a mission. Moreover, hybrid rocket engines are environmentally friendly. The fuels used are typically non-toxic and produce less harmful emissions compared to other rocket engines. This makes them a more sustainable choice in the evolving field of aerospace engineering. Still, like all great inventions, hybrid rocket engines have their challenges. They're not as powerful as their liquid or solid counterparts, and they're more complex, which can lead to issues with scalability and performance. As we delve deeper into this topic, we will discover how hybrid rocket engines have evolved over time and the key players in their development. So buckle up and prepare for a journey into the heart of these remarkable engines. The promise of space exploration is just a hybrid rocket engine away. To understand the importance of hybrid rocket engines, we need to go back to where it all started. The journey of hybrid rocket engines began with the formation of Space Propulsion Group in 1999. This group was founded by Arif Karabioglu, Brian Cantwell, and other brilliant minds from Stanford University, with the goal to develop high regression rate liquefying hybrid rocket fuels. They successfully test-fired large motors and are known for developing the liquid layer combustion theory for hybrid rockets. Even today, the Stanford's Space Group is actively working with NASA Ames Research Center on the Peregrine-sounding rocket project. On another part of the globe, the Istanbul Technical University's Pars Rocketry Group made a significant contribution by designing and building Turkey's first hybrid rocket engine, which was extensively tested in May 2015. Meanwhile, in the United Kingdom, a team known as Lafingas took a unique approach by incorporating 4 nitrous oxide hybrid rockets in a drag racing style car. They cleverly used a fuel grain of high-density wound paper soaked in cooking oil. Italy also made its mark in the field with SISAS, G. Colombo, University of Padua. They covered all stages of development, from theoretical analysis of the combustion process to conducting ground tests of rockets. The research group has been focusing on the use of high-test peroxide as oxidizer since 2014. Taiwan also entered the hybrid rocket race in 2009, with 2 university teams developing nitrous oxide, HTPB propellant systems. The teams have successfully launched several rockets, reaching altitudes of 10 to 20 kilometers. In Germany, the University of Stuttgart student team HyEnd holds the current world record for the highest flying student-built hybrid rocket with their Heroes rockets. The genesis of hybrid rocket engines wouldn't be complete without mentioning the contributions from Bangladesh's Amateur Experimental Rocketry Dhaka and Austria's TU Graz Aerospace team, both of which are working on exciting projects in the field. The foundation for hybrid rocket engines was laid by these early pioneers, setting the stage for future advancements. From their initial conception, hybrid rocket engines have seen significant advancements. Let's delve into some of these significant developments and the institutions that have been pivotal in pushing the boundaries of this technology. The Space Propulsion Group, formed in 1999 by individuals from Stanford University, has been a trailblazer in the field. Their work in developing high regression rate liquefying hybrid rocket fuels has led to the successful ignition of motors as large as 12.5 inches in diameter, producing up to 58,000 newtons of force. This groundbreaking work has led to the development of a 24-inch diameter, 110,000 Newton motor. Moving across the globe, the Istanbul Technical University in Turkey designed and built the country's first hybrid rocket engine. Extensively tested in May 2015, this marked a significant milestone in Turkey's space exploration endeavors. Over in Italy, the Center of Studies and Activities for Space at the University of Padua has been leading research in hybrid propellants rockets. From theoretical analysis of the combustion process to numerical simulation and ground tests, their comprehensive approach has led to several successful engine launches. Their research group is now focusing on the use of high-test peroxide as an oxidizer, showing promise for future developments. These institutions have been instrumental in the progression of hybrid rocket engines, each contributing unique advancements to the field. The work of these organizations has not only enhanced the performance of these engines, but also expanded their potential applications. From space exploration to nano-satellite launch, the possibilities are vast. So it's safe to say that the progression of hybrid rocket engines has been a journey of innovation and discovery. With the continued dedication of these institutions and their focus on overcoming engineering challenges, the future of hybrid rocket engines looks bright. These advancements have not only improved the performance of hybrid rocket engines, but also widened their applications. Today, hybrid rocket engines are being developed and used by various organizations across the globe. The advancements made by these organizations are driving the evolution of rocket technology, and it's quite fascinating. Let's take a journey around the world and see what's happening. First stop, Taiwan. Here, the development of hybrid rocket systems began in earnest in 2009. Two university teams, working under the National Space Organization, have successfully launched several hybrid rockets, reaching altitudes of 10 to 20 kilometers. Their future plans are ambitious, aiming to test nano-satellites at altitudes of 100 to 200 kilometers, and eventually developing orbital launch capabilities for nano-satellites. Next, we fly over to Germany. The University of Stuttgart student team HyEnd holds the current world record for the highest flying student-built hybrid rocket. Their Heroes rockets have certainly made a mark in the world of hybrid rocket technology. In Bangladesh, we find the Amateur Experimental Rocketry Dhaka, supported by the American International University Bangladesh. They have tested the country's first hybrid rocket engine, a significant achievement. Now they are working towards developing larger paraffin nitrous oxide-based prototypes. Finally, let's land in Austria. The aerospace team of the TU Graz is doing commendable work in developing a hybrid propellant rocket. Their efforts are a testament to the global interest and dedication in advancing hybrid rocket technology. These examples are just a drop in the ocean. There are many other organizations, universities, and research groups across the globe tirelessly working on hybrid rocket engines. They are pushing the boundaries of what's possible, overcoming technical challenges, and creating solutions that will propel us into the future. The development of hybrid rocket engines continues to progress, with new advancements being made regularly. It's an exciting time in the world of rocket technology, and we can't wait to see what the future holds. As we have seen, hybrid rocket engines have come a long way since their inception. They have grown from a concept to a reality, a testament to the power of human innovation and determination. Hybrid rocket engines are important because they offer a safe, efficient, and environmentally friendly alternative to traditional rocket engines. They combine the best features of liquid and solid rockets, offering the safety and simplicity of solid rockets and the efficiency and controllability of liquid rockets. Organizations across the globe are working tirelessly to further develop hybrid rocket technology. From the Space Propulsion Group at Stanford University, which is pushing the boundaries of hybrid rocket fuels, to the Pars Rocketry Group at Istanbul Technical University, which has built the first hybrid rocket engine of Turkey. These teams are creating powerful engines that can reach altitudes of over 100 kilometers. In the United Kingdom, a team is even using hybrid rockets in a drag racing style car, showcasing the versatility of this technology. Meanwhile, in Italy, the Center of Studies and Activities for Space at the University of Padua is conducting ground tests of small and large-scale rockets, And in Taiwan, teams are developing orbital launch capabilities for nanosatellites. The future of hybrid rocket engines is bright. With every test, every launch, we are learning more about these versatile engines. We are finding new ways to make them more efficient, more powerful, and more reliable. We are discovering new applications for them, from space travel to transportation. But the journey is far from over. There are still challenges to overcome, mysteries to solve. Each day brings new opportunities for discovery and innovation. With continuous research and development, the future of hybrid rocket engines promises to be exciting. So stay curious and keep exploring the fascinating world of rocket science.